I gave a lecture, but I deleted it. I gave a lecture, but I deleted it. Okay, so if we go to the games directory, demo games, there's a file called vroom, and this has graphics and ASCII source code. Some people think the .z's are collections of files, but they're actually just one file. A .z file, they're individually compressed. What adds to the confusion is graphics and source. A lot of people think it's a graphics file and a text file. It's not. It's one file. The graphics go at the bottom, and the text goes here. And you can't append. You can't just add text to the end of the file. So what I'm okay. So if you're familiar with virtual memory, maybe one process has maybe this goes to physical memory. So this goes to some physical memory, and process 2, let's say you have this one going to 4, 5, 6, 7. Maybe you're doing this so that they both have low memory for global variables and stuff. Maybe, and anyway, so let's say you want to add, well, this is not where a stack is normally placed, but let's say you want to add, then you're going to put it at 1. You can do this because it's virtual memory. Paging, not virtual memory. Paging. Anyway, these are virtual addresses, and there's a now. With the file system, with the FAT32 file system, you have block 1 goes you might have something like that. I don't know. That's the end of file. So this is oops. Wait a minute. One. Okay. Oops. So let's say you have a couple files. This is file 1, and this is file 2, and this is your FAT table, the file allocation table. Let's say you want to add. Let's say you want to grow. Let's say you want to grow file 1 by a block. So what you do is you set number 6 to. We want to grow it. You set this to be the end, and you set this to be number 6. So these can get all scrambled, and that's what defragging was all about. If you move the disk head in order, it's faster. So instead of jumping around. Now, the way we operate with TempleOS is we want to keep it simpler, and so we don't use no paging. So what does that mean? That means that all we have is physical addresses, and the red C does not use a FAT table. No FAT. It's just allocation bitmap. Okay. So you can see how we're doing the same thing with the disk that we do with memory. We're trying to keep this for beginners. We want to cherry pick some things. When working together, the whole operating system is designed for whole files. So like we saw here that we can't add text to the bottom because there's graphics. So you have to read and write the whole file. Also, these are compressed, and if you have a compressed file, you can't add to it or subtract from it. So compression is by nature done on whole files as well. And so anyway, so the Red Sea file system is okay. I'm going to copy the home directory to the B drive, which is if I do a drive report, the B drive is a Red Sea RAM disk with 100,000 blocks. The C and the D are hard drives, hard drive partitions. This is where the gap, it starts at 3F. The bootloader goes before it normally, but in my operating system I put the bootloader in the file area. Anyway, we want to go to the B drive. So there's a special directory command called and you can say true, gives you a full directory. This gives cluster numbers. The Red Sea does away with FAT tables. It also does away with clusters, cluster numbers. It's just blocks. With FAT, they allocate like, let's just say 16 blocks at a time, because it's not worth messing with smaller sizes. And if you allocate 16 blocks at a time, it's more it takes less time and less storage and stuff. So instead of 16 bits, you have just 1 bit. But we want to keep it conceptually. Our goal is to make something that's fun to hack and educate yourself. So these are block numbers, not clusters. There's no difference between a block and a cluster. So if I say dump block, this is the block for dot. Dot is the current directory. So I'm going to say dump block. So this is the current directory. It's got 64-byte entries. If we want, we can see this is the structure. Anyway, so the first two are this area is copied directly into and out of memory. That chunk, so that it's got 16 bits of attribute. You can see the 10 is a directory. The 10 is a directory. These are directories. This is not a directory. Do it once is not a directory. Web, the first several were directories. Then the name, the home. This is the home directory. It's kind of weird that that's like that, but anyway, home directory. Then this is the block number, 015260. 015260. So 015260 is the cluster number, block number, and the size is 600. 600 is the size. You can see that up here. 600 is the size of the dot directory. And then it's got the date time. This is the upper 32 bits are days. The lower 32 bits are a fraction of a day. And so that works out to 47. Let's just see. So if we have fractions of a day, 0x1, 1, 2, 3, 4, 1, 2, 3, 4, divided by 24, divided by 60, divided by 60. So it's accurate down to 49 thousandths of a second, and it's days. The upper 32 are days since Christ's birth. So year 0 AD is the 0 date. Unix is 1970. Anyway, so it's 64 bits. I have my own date time routines for doing all this. Anyway, so the name is 38 characters maximum, and it includes a 0. So you have to have the 0. That's just to make so that we can copy this directly to the disk, directly to memory, and it's now let's do check disk. I tried this earlier today. I had errors. Okay, no errors. Okay, we're gonna look at the so C drive star DV equals letter to. This is the internal structure for the B drive. We can do a class rep DV. So this is this tells the root cluster is number 102. The fat tables start at block 1. 1 is the first allocation table. It's for this is the allocation table. There's only one on a fat system. You have a couple allocation tables. We just have one. We don't have that redundancy. We don't have a bad block table. It's ultra simple. So the size is 100,000. So if we have one, bit for each block, then how many blocks of allocation do we need? We need there's 512 bytes per allocation block, and 8 bits per byte. So we need 100 blocks for allocation, and we need 100 blocks for allocation. We need 100 blocks for allocation. We need 100 blocks for allocation. The first data area, this is the first file block, is 101. All these numbers are hexadecimal numbers, except those. Anyway, so let's take a look at the dump. Block 0 is the boot sector. We don't have a you can't boot this, so there's no code in here. There's some other stuff in there. Anyway, so block 1 is the first allocation block. Now, if we do a drive view, okay, this is showing the allocated clusters. So the first, The first few are allocated solid allocation. So I just did this earlier today. Let's look at block 20, 21, 22. So 22 is where the allocation ends. So watch what happens if we let's create junk.text, and we're gonna make a text file. Okay, I just created a text file with a bunch of junk. Now let's dump this block again and see what happens. Look, there's do you see the difference? Do you see there's a 7F? So that means we allocated 4 plus 3. We allocated 7 blocks for it. Let's see what the directory says. Junk is D, so that's 13. Let's look at the size. D7B is okay. 3451 divided by 512.0. So it is 6.7 blocks. So we need 7 blocks. So so now let's do a check disk. Okay, the check disk verify everything looks good. Now let's do a dump block. Let's first of all let's write the. I was going to demonstrate that we can write files, so we can write blocks. So let's go ahead and modify the directory itself. We say true, and that means write. So as soon as we hit escape, it's going to write this block. So we can edit it, and we can change Budweiser. I'm going to hit escape. And now directory, it says Budweiser is the name of the directory. So now I'm gonna do a check disk. Okay, I'm going to do a dump block, let's say 0x21. No, let's say 21 hexadecimal. Okay, now let's do comma true. Now we can edit. Let's unallocate a block that's supposed to be allocated. So I'm going to change that to 7. I'm going to hit escape. Now I'm going to do a check disk. It says unallocated block, and then it gives a file. It gives a cluster number. Let's convert this to the right location and see if it's block 21. So we say 0x divided by 512 divided by 8. 512 blocks per allocation block. 512 bytes per allocation block. 8 bits per byte. So this is in the middle of block 21, in the middle of block 20. In the middle of block 20, and then there's also the FAT starts at block 1 because block 0 is the boot sector. So it's so that's where it is. Let's see if we can fix it. So we can come up here and fix it. And then we can do check disk, and it's good. So we fixed it. So with the Commodore, everybody learned what a block was, and you had understanding of what the hell was going on. Bill Gates says abstraction layers are like condoms. You should wear 3 abstraction layers. Or what, are you a terrorist if you don't wear 3 condoms? Are you a terrorist? Somebody accused me of being a terrorist for explaining blocks to people. They want nigger cattle. Just dumb fucking people that have no clue. You can herd them and sit there with glazed eyes. Anyway, so that's the Red Sea. So we're going to make Microsoft support Red Sea. We're going to put, right now we have FAT, Red Sea, and ISO 9660 for CD-ROM. What we're going to do is we're going to bulk copy a Red Sea onto the CD-ROM. We're not going to have multiple sessions there. Now, what that's going to enable me to do, we have I set a limit of 100,000 lines of code for the operating system, and that's for when you press F1. I want you to be able to get your head around the whole thing and say, I can master this. This is not hard. To see the light at the end of the tunnel. Right now we have I have a limit of 100,000 lines of code. There's the demos don't count towards the total. We're at about 80,000. But once we get Microsoft to support Red Sea, then we can come in here and we can get rid of FAT32. FAT is really blemished. It's ugly. God said it has to be perfect. And ISO 9660's it's got crazy. It has international characters, and it has 2 sets of directories and a bunch of crazy shit. It's got big endian and little endian, and we're going to get rid of 970 lines of code, 293 lines of code, and then there's the I have we're not going to be able to get rid of this, but I have an ISO file creator, and if I can just copy a Red Sea onto the disk, it's a lot easier. It's a little easier. Anyway, so Microsoft is going to do what God says, and let's go ahead and see if they shut down the NIST numbers. They're still shut down. Oh well. We can go. We're going to take the first 5 decimal digits out of hot bits. Hot bits are Geiger counter numbers. First 5 decimal digits, and it's going to be a line number. 58373. So we go to line number 58373. Foundations of Kirheseth shall ye mourn, surely they are stricken. For the fields of Heshbon languish, and the vine of Sibmah. The lords of the heathen have broken down the principal plants thereof. They are come even unto Jazer. They wandered through the wilderness. Her branches are stretched out. They have gone over the sea. Therefore I will bewail with the weeping of Jazer. The vine of Sibnah I will water thee with my tears, O Heshbon and Eliel, for the shouting of thy summer fruits, and for thy harvest is fallen. And gladness is taken away, and joy out of the plentiful field. And in the vineyards there shall be no singing, neither shall there be shouting. The treaders shall tread out no wine in their press. I have made their vintage shouting to cease. Wherefore my bowels shall sound like a harp for Moab, and my inward parts for Keresh. And it shall come to pass, when it is seen that Moab is weary on the high places, that he shall come to a sanctuary to pray, but he shall not prevail. Okay. Anyway, Vine reminds me of blockchains. That's not much of a miraculous drawing. But somebody keeps thinking that I plan to do blockchains, but I don't want to do blockchains. I have no plans for blockchains. What that would enable would be adding to files. No, we don't want to do that. We don't want to add to files. You read the whole file, you write the whole file. There's file read, there's file read, file write. You work with a if you have a text file, if you're doing a text file application, you work with DALDocs. This has some examples of how to work with text files. Go to the file directory, demo disk. There's an example. Sort files. This shows sorting text and binary data in a file. Anyway, so Microsoft is going to support Red Sea. Let's see what God says. Fuck you, Mom. Fucking coughing up. Decompressed, non-objective, Iberia, Missy, Cabernet, Simpered, announced, Backers, Ella's, Vinegar, Unruly, Wince, Aral, AWOL, Motorized, Untrustworthy, Jody's, Wisteria.